Find the values of the function for which the function has a local maximum and minimum, and determine which are maximum and which are minimum. And then b, f of x has a global maximum and a global minimum. So first, we are giving this function, and it's the interval between 0 and 2. So what we're gonna do, we'll find a critical point and apply the test to check if they are local maximum or minimum. So first, a critical point is where the first derivative is 0 or undefined. This is the first derivative. Notice the first derivative function is defined for all values of x, including the given interval 0 to 2. Now, whereas the first derivative is 0, it's gonna be when 10x9 minus 1 is 0, and that's gonna be when x equal to 1. Now, notice this x equal to 1, it's in our interval from 0 to 2. Therefore, it's considered a critical point for the function. Now, we want to test this critical point is a local maximum or a local minimum. So here, I can do the first derivative test or the second derivative test. I choose to do the second derivative test. So the second derivative test, I'm gonna evaluate our critical point, and the second derivative of the sign are positive, then it's a local minimum. If it's negative, then it's a local maximum. So this is the second derivative function. Now I'm gonna evaluate the second derivative at 1, and it's gonna be a positive number. Therefore, the second derivative tells us that the function f of x concave up, and this is the shape of concaving up. You can see we will have a local minimum at x equal to 1. Now this is for part A. For part B, we want to find a global maximum or minimum for the function. Notice this is a closed interval. This means we are guaranteed to have a global maximum or minimum. So what I'm gonna do here, I'm gonna evaluate our critical points 1 and our endpoint 0 and 2, and the function f of x. The highest value gonna be global maximum, the lowest value gonna be global minimum. So here you can see that we have highest value when x equal to 2, and then we have lowest value of the function at x equal to 1. Therefore, at x equal to 1, we will have a global minimum, and then at x equal to 2, we're gonna have a global maximum. Now, find the global maximum and minimum for the function g of x equal to x minus sine of 2x on the interval 0 to pi over 2. Notice this is a closed interval, which means we are guaranteed to have global maximum and minimum, and then we are going to follow the steps of a closed maximum to find a global maximum or minimum. So the first step is to find a critical point. It's gonna be where the first derivative is 0 or undefined. This is the first derivative. Now notice that the first derivative is defined on the interval. Remember, our interval is between 0 to pi over 2. Now where's the function, where's the first derivative is 0, it's gonna be when 1 minus 2 cosine of 2x equal to 0. I'm gonna move the 1 to the other side, and then I'm gonna divide by 2. And then I'm gonna take the cosine inverse, or the arctan of cosine, on both sides. So on the left side we'll end up with 2x, and on the right side gonna be cosine inverse of half. And then I'm gonna divide by 2. Now notice what's the value of cosine inverse of half. So here, this is the graph of cosine. Notice this is half. Half is y, and cosine inverse of half, we want to find the value of x, and gonna happen periodically at y equal to half. So that gonna be at pi over 3, and then 5 pi over 3, and so on. However, our interval, it's only going from 0 to pi over 2. Therefore, the only point that included is only pi over 3. So now the value of the cosine inverse of half, it's going to be pi over 3, and then gonna multiply by half and gonna be pi over 6. And again, pi over 6 is in our interval from 0 to pi over 2. Therefore, it's considered to be a critical point. So the second step, I'm going to evaluate our critical point, which is pi over 6, and then I'm going to evaluate our endpoint, which is 0 and pi over 2. The highest going to be a global maximum, and the lowest value going to be a global minimum. Now we can notice that we have highest value at x equal to pi over 2 and lowest value when x equal to pi over 6. Therefore, at x equal to pi over 2, we're gonna have a global maximum. Why? Because it's the highest value of the function. And at x equal to pi over 6, we're gonna have a global minimum. Now this is the graph of the function g of x. Notice this is our interval. It's going from 0 to pi over 2. At pi over 6, we have local minimum, as well as this is a global minimum, since this is the lowest value on this interval. And then at pi over 2, this is the local and the global maximum. Global because this is the highest value of the function.